Hi everyone, and welcome to this month's Connect with Control M. My name is Melvin Abraham, and I'm a Control M Technical Support Analyst serving the Americas region. Our topic today is troubleshooting Control M Server high availability environment with dedicated PostgreSQL, and I'll show you how to identify and correct a few common issues that can occur when setting up a high availability environment. All right, let's take a look at the agenda for today. During this webinar, I'll describe the general architecture of a control room server high availability environment and how the process interacts with each other. Next, we'll look at a few possible scenarios that can cause the high availability feature to not work when you're using a dedicated PostgreSQL database. We'll wrap up with the Q&A session where we'll go through the questions that you posted during the webinar. Now let's talk about the architecture. Control room server high availability architecture can be broken down into two. This particular slide illustrates the architecture using an external database such as Oracle, MS SQL, or external PostgreSQL. Control room server high availability enables you to install a secondary instance of control room server, and if there's a failure or you need to perform a hardware or OS maintenance, for example, on the primary host, control room continues to run on the secondary host. When a failover is executed, the jobs continue running on the control room agents, and the status is updated on the secondary control room server as soon as the failover is done. Generally, there are two servers with control room server software installed. One is the primary node, and the other one is the secondary node, which is the non-active node in this illustration. Two installations are sharing the same external database that has been prepared before the product installation. So in order to obtain a reliable high availability installation when using an external database, we recommend database should be installed on a third node to avoid any downtime in case of a failure of one of the two control room server nodes. On the primary node, we have all the control room server processes up and running as you would normally have in a standalone installation. While on the secondary node, only the control room server configuration agent is up and running, and all the other processes are kept switched off. Configuration agents on the primary and the secondary talk to each other using network connections and uses port 2368 and 2369, and both of them access the database to read and write information. When you do a failover from the primary to the secondary, it can be caused either by a manual operation using a command or automatically when the secondary configuration agent realizes the primary environment is now responding. And the configuration agents are responsible to activate and deactivate the processes on the two nodes in order to maintain the availability of the control room server functions. Now, to establish a control room server in high availability environment, you have to install the primary node as you normally would on a standalone installation. And once the primary control room server is up and running, you can start the installation on the secondary node, selecting the relevant options in the installation menu, which will enable the high availability. Once the installation is completed, it will mark the first node as a primary and the newly installed node as secondary. And all the configuration information are actually kept in the database tables. We'll take a look at the architecture when it comes to using the dedicated PostgreSQL. And this illustration presents that architecture, and installation process for this is similar to the other architecture using the external database, except when using the dedicated PostgreSQL, you need a shared drive on a third node that's accessible to both primary and secondary configuration agents. And these primary and the secondary configuration agent will need read and write access to the shared drive as well. This shared drive needs to be available always, and it will be used to replicate data from both primary and secondary. On the primary, the control room server and the dedicated PostgreSQL database will be installed together. And once the control room server has been installed on the primary node, you can proceed with the secondary node installation. Similar to the primary node, both control room server and the dedicated PostgreSQL database should be installed on the same node in the secondary as well. And in this architecture, control M server configuration agents are communicating with each other directly, but they're also looking at the configuration data on the database to further strengthen the high availability. This illustration shows the high availability environment and how it is presented in the Control M Configuration Manager in a normal situation in which the two primary and the secondary nodes are communicating and the high availability is active using the dedicated PostgreSQL database. In the tree view on the left of the window, there is a list of the components in this Control M server environment. And selecting the high availability menu at the top, you get the relevant buttons for the HA environment. And under the properties pane on the right, we can see the references to the two control server nodes, primary and secondary, and the state of the HA environment, which is running on primary in this illustration. This messages area is one of the important areas in the configuration manager. And in this area, we can see the database's replicated message, which means the data required for the secondary node has been replicated to the shared drive, and the environment is failover ready if necessary. This message area will display messages from all the components involved in the control server high availability. These components include the database, shared folder, and the control server configuration agents. In a normal situation like this, failover to secondary is enabled, allowing you to manually force the secondary node to become active and run the control server components on the secondary. Today in our demo, we'll have a scenario in which we have just installed the control server on the secondary node with dedicated BMC provided PostgreSQL database, and we'll need to get our high availability active and failover ready. So this environment is currently not available when it comes to HA, and this puts our application at risk. So we'll investigate to find out the root cause of the issue and fix it. And before moving on to the live demo, let's take a look at the results of our first poll question. And more than half of everyone here has implemented the HA feature of the control server, which is great. And I'll also ask my second poll question right now. Would you prefer to use control HA feature or another clustering solution? All right, let's move into our demo. Here I have a control configuration manager, and you can see the control server environment here that I just installed. And if we look in the properties pane, you can see the information regarding my primary host, secondary host, and the current state of my environment, which is running on primary. If you look in the high availability menu, none of the HA related buttons are active. So we'll look in the messages area here to see what the messages are and why the HA is not active yet. My first message is secondary configuration agent is unavailable. So we'll take a look at our secondary control server. My control servers are installed on Linux servers, and I'm already logged into my control server as my control user, which is CTM user. So I'll go ahead and run a utility called show_CA. This is a control server utility that will show you the control server configuration agent process if it's running. And I did not get any output return back. So let me go ahead and start my configuration agent. This command can be used to start the configuration agent, or you can also start the configuration agent through the CTM_ menu. All right, control server configuration agent started. And let's go ahead and run that show CA command one more time. And if you notice, it will tell you the control configuration agent is running and the process ID for that, and also the port that we're using. Now that our configuration agent is running, let's go back to the configuration manager and let's take a look. it will take a few seconds for the primary control server to communicate with the secondary configuration agent, and looks like it did, and that message went away. But our buttons are still not active, that meaning our HA is currently not active. So let's take a look at the messages area again, and high availability is not activated since the replication process was not started. And the reason for that is primary configuration agent cannot access the shared directory. So that usually means my primary configuration agent is not able to talk to the shared NFS mount. This is my primary control server, and I'm logged in as my control user here. We'll take a look at the shared mount. It's under /home/CTM share, and it's on this NFS server. So it's mounted correctly, and it looks like I have enough free space. So let me go ahead and try to create a test file in that shared directory from the primary control server as a control user. I'll use a simple touch command, and I'm getting a reply back saying the permission denied. So it looks like I'm not able to write to my shared drive from the primary. So let's go ahead and take a look at the secondary and make sure I have access here. The NFS mount is mounted similarly as the primary in the secondary. It's under home_CTM share/CTM share, and it's on the same NFS server. I'll go ahead and run a touch command here to make sure I have the access from the secondary, and looks like I'm getting permission denied here as well. So both my primary and secondary control server are not able to write to the shared drive. So at this point, usually you would reach out to your system administrator or your storage administrator regarding this permission issue. In my case, I'm the one who provisioned the NFS server, so I have root access to this. Let me go ahead and go to the home directory and do a list. And as you can see, here's the CTM share, and the permission on that is only read for the user and the group. So I'll go ahead and change the permission using the chmod command. And let's go ahead and list it again to make sure the permission has been changed. All right, so CTM share permission is changed where the user and the group should be able to read and write to this directory now. So let's go back to the primary control server, and I'm going to run that touch command one more time. I didn't get a permission denied message, which is good. So it usually means I was able to successfully create the test file. Let me go ahead and list that test file from here. And here it is. So I was able to create the test file from the primary. So since this is only a test file, I'm going to go ahead and remove this file. Let me do the same test from the secondary control server and make sure that I'm able to access and read and write to the shared drive. And looks like I am. And I'll go ahead and list it to make sure I'm able to read. That looks good. So I'll go ahead and remove the test file since it's not necessary to have it here. Now that we know our primary and the secondary control server can access the NFS mount without any issues and have the correct access, we'll go back to the configuration manager, and looks like the message area has cleared up regarding the access denied message, and now we're seeing high availability is not activated since the replication process was not started. If you look in the high availability menu on the top, now our Start Database Replication button is enabled, so we can go ahead and start the replication. Database replication, what it does is it will copy the whole PosgreSQL directory from the primary control server to the shared drive. And from the shared drive, it will be copied to the secondary control server so that the Postgres database on the secondary will be synced with the primary Postgres database. Once the replication is finished, both databases will be synchronized by using the Postgres archive files in the shared drive. The amount of time it requires to take a snapshot of the database depends on the size of your database and the network connection between the primary or the secondary node and the NFS mount. Even if the database is replicated, if you lose access to the shared drive, you will not be able to do a failover. So now that the replication is going on, we'll take a look at the contents of that shared directory. Let me go to the CTM share and do a list. And here we can see the files that are created through the replication process. Archive logs is where the Postgres archive files are copied over from the active node in the HA environment. This keeps both primary and secondary databases in sync. There are some few test files that are created by the primary and the secondary control configuration agents. This is just to make sure the agents have the access to their shared drive. CTMHA archives server underscore params .dat. This file is an important file, and we strongly suggest you do not make any changes manually in this file. We can take a look at the contents. It pretty much have the information regarding your active host ID, primary host ID, secondary host ID, etc. from your HA environment. And the snapshot directory here, this is where the PosgreSQL directory is copied over temporarily during the replication process. And once it's copied over to the secondary or the non-active node, it's removed from this directory. Okay, looks like our replication is completed in the background. The message area displays databases is replicated, and now our environment is HA ready and is ready to be failed over if necessary. And failover to the secondary can be initiated from this button in the configuration manager, or let's say in a scenario where you lose access to your enterprise manager server and you don't have access to the configuration manager, but you need to do a failover of your control room server. You can do this through a CTM IPC utility, a command utility that we have for the control room server. So in order to do this, you need to run this command from your active node in the HA environment. In my case, it's the primary control room server. So here's the command, and I'll go ahead and run that. This command will send a message to both control room server configuration agents. This message means the manual failover needs to be performed. So if you go back to the configuration manager, if you have access to it, we'll see a banner popping up here that has a message: the failover is in process. There it is. And what it does is it will bring down the control room server on the primary, and it will start up the control room server process on the secondary. All right, now that the failover has started, it might take a minute or two depending on the replication time. So we'll conclude our demo here and let's go back to the presentation. All right, so here's what the control and configuration manager will show after the failover action is completed. It will display the current active control and server HA configurations in the properties pane. And we can also see that control and server is currently running on the secondary node. And we also have a date that indicates when the last failover or fallback was done. Additionally, the status of the environment is set to warning since running on the secondary node is considered as an exceptional situation. And in the messages area, we can also see the replication process was not started. The commands that are active under the high availability menu are now different after a failover to the secondary. We have the button fallback to primary, which can be used to move back the control and server processes to the original node. And we also have a button called set as primary, which is an option that must only be used if the primary node is unrecoverable and you need to reinstall the control room server. And it is not necessary to click the set as primary option after a normal failover, especially when you're planning to do a fallback. Let's do a recap of what we discussed so far. We discussed briefly about the control room server high availability architecture, both using an external database such as Oracle, MS SQL, or external PostgreSQL, and using the dedicated BMC provided PostgreSQL, which is what our demo was about. During our live demo, and we looked at the control room server HA environment and possible issues that you could run into with the shared drive and how to troubleshoot and fix these issues. We also looked at the set as primary button that becomes active when you do a failover to the secondary, what it is and when it should be used. Also, as a reminder, if you have a firewall in between primary and secondary control room server nodes, you will need to open ports 2368, which is used for HA, 2369, which is used by the configuration agents, and 5432, which is only open if you're using the dedicated PostgreSQL database, as we did in our demo. Let's take a look at our second poll question. And 87% of everyone here prefers to use the control room server HA. All right. Now, before heading into the Q&A section, I want to provide some helpful resources here for working with the control room server high availability. You can also find links to these knowledge articles in the attachment section. I really hope you find this information helpful. Thank you very much for taking time to join this webinar.